Hi everybody, this is the last video for the endocrine system. This video is going to cover the pancreas, pineal gland, and thymus. We're going to start on page 15 of your course pack if you'd like to follow me there. We're going to first talk about the pancreas, which is a triangular shaped organ situated behind the stomach and hooked here into a portion of the small intestine that's called the duodenum or duodenum. So this organ actually has two purposes. It functions as an endocrine gland and also as a digestive organ. We're going to save the digestive organ conversation for later on in this course and right now focus instead on its endocrine function. This picture shows part of the cell setup inside of the pancreas, and we're going to ignore the ductwork here right now because this tubing that you see here through the middle is actually where the digestive juices get carried into the small intestine. We're going to instead focus on a different set of cells. These cells here called islets of Langerhans. They are sometimes simply called the islet cells found in the pancreas. They're the ones secreting hormones. Now, you know that hormones do not need to travel in ducts like you see here. Instead, these hormones are then sent from these islet cells into the bloodstream, and that's how all of our hormones travel. There are two types of hormones produced here. They both regulate blood sugar levels. They are called insulin and glucagon. Here you can see a more close-up look at those islet cells in the pancreas. Now, there are specific cells here called beta cells. Those beta cells produce insulin. And there's another kind of cell called an alpha cell. And if you've got to have a trick here to keep it straight, there's a bunch of A's in alpha, right? Okay, and there's an A here in glucagon. That's just how I keep those two straight, that beta cells produce insulin and alpha cells produce glucagon. Both are types of islet cells found here in this picture. So these two hormones do opposite jobs. So we call them antagonists because they play an opposite role in regulating blood glucose levels. The pancreas acts as the regulator for blood glucose. When blood glucose levels are too high, then insulin is produced by beta islet cells. The job of insulin is to lower blood glucose levels. Now, the job of glucagon is opposite. It's produced by those alpha islet cells, and it raises blood glucose levels. So blood glucose is oftentimes measured at fasting, and we look at, say, around 70 to 120 milligrams per deciliter of blood. If blood glucose levels are too high, then we decrease using insulin. And if blood glucose levels are too low, we raise using glucagon. So they do work opposite of each other as antagonists. These two hormones also operate under humoral control. Keep in mind that term there has a meaning. It says to us that we are looking at the blood concentration of sugar. And so if blood concentration is too high or too low, one of these two antagonistic hormones is released by the pancreas. This is a good time to bring up other hormones that increase blood sugar levels. We've talked previously about cortisol increasing blood sugar. And we've also talked about epinephrine and its buddy norepinephrine. And now we know that glucagon also raises blood sugar levels. And so the only one to decrease blood sugar levels in this list is insulin. So just something to keep thinking about is what we've talked about so far in the past. Now's a good time to talk about a form of diabetes that comes from insulin insufficiency called diabetes mellitus or mellitus. The term mellitus or mellitus means sugar or sweet or honey-like, and so that's where this particular disease was diagnosed from. Greeks actually knew about diabetes because they tasted urine and found it to have a sweet taste of those who suffered from diabetes mellitus. Now, we've talked about a form of diabetes earlier called diabetes insipidus. These two disorders share two symptoms in common. They share polyuria and polydipsia. The symptom that stands out and makes this particular disorder unique is polyphagia. So I want to make sure that we know that that is a distinguishing symptom. That is increased hunger due to the loss of glucose in the urine. Other symptoms that come along with this particular form of diabetes are nausea and vomiting, Type 1 diabetics may have ketoacidosis, which produces a fruity odor to the breath. Very unusual smell, I might say, if you've ever smelled someone's breath who's experiencing ketoacidosis. One non-scientific way to tell if blood sugar is high is the skin feels hot and dry, or cold and clammy when the blood sugar is low. Long-term diabetic complications can include eye damage, blindness, heart damage, and cardiovascular disease. The kidneys can fail from the excess sugar, and limbs may need to be amputated due to the poor circulation. People with diabetes also have sores that may not heal properly. That's why it's important for them to wear shoes, for instance, because they may not feel damage done to their feet. We often divide diabetics into two types, type 1 and type 2. Type 1 diabetics are those who are insulin dependent, while type 2 typically develop later in life due to diet or exercise issues and can be treated with diet and exercise changes. So when we talk about diabetes mellitus, let me emphasize it is not the same as diabetes insipidus. This particular disorder here is due to a lack of ADH, while diabetes mellitus is due to a lack or insufficient production of insulin. Be sure you jot down these 3 classic symptoms on your worksheet, page 15, under 3 cardinal signs. I also want to mention at the very bottom of page 15, here are your type 1, type 2, and gestational diabetes information listed. Interesting research being done out there right now. There are ways possibly to transplant some cells into the pancreas that allow the pancreas to produce insulin. That would be a great solution for anyone with a form of diabetes to be able to make adequate levels of insulin if it in fact is type 1 where there's not any secretion, or type 2 where there's insufficient secretion of insulin. If you'll turn on over to page 16 with me, let's spend a moment talking about the pineal gland or pineal body. This particular piece of tissue in the brain is found back here near corpus callosum, and it produces one hormone that we'll discuss called melatonin. Well, we know this particular hormone is responsible for regulating your sleep cycle. Levels of it will increase toward the evening. That's what allows you to become sleepy. We also think that melatonin regulates sex drive and perhaps even female menstrual cycles. All of this based upon your exposure to sunlight. So it's critical that we're exposed to sunlight to help us regulate this circadian rhythm, our biorhythm, knowing when to be awake, when to sleep, and also we think it may regulate these reproductive cycles. Interesting thing to think about here. What influence do you think melatonin has for someone who is blind? Well, someone who has no vision and cannot detect sunlight through their eyes may end up having difficulty regulating their day and their night cycles. Interesting side note, we think this particular hormone is responsible for the coat changes of animals during winter. You know, sometimes they'll develop a white coat to match the snow. And we also think it may play a role in seasonal affective disorder, those who have, you know, the wintertime blues due to less sunlight in that particular season. Interesting, only 3 years ago in 2017, of course this year is 2020 when this recording is being made, we have learned a little more about how melatonin plays a role in alertness and sleep. So interesting stuff still being done on these hormones. There's still more to learn about this information. The last endocrine gland is our thymus gland, and it sits beneath your sternum over the heart, and you can see right here it is further down in the chest cavity than is your thyroid. That's the thyroid up here. Okay, so thymosin is the hormone produced here. That should be easy to remember, right? Kind of sounds like Thymus Gland. And this particular hormone is productive during your childhood years when your body is programming your immune system. So you say, well, you know, what happens when I reach 25 and my thymus gland has, you know, pretty much shriveled? You know, what happens if I catch a disease then? How do I protect myself against, you know, foreign invaders like viruses? Well, after your thymus gland tends to shrivel, you have other locations in your body that still program your immune system. One location is another T word, your tonsils. So just another good reason to hang on to those tonsils if you can, since they are also involved in helping to program your immune system, these T cells. Now, if you happen to have a course pack handy, there are worksheets on pages 17, 18, and 19. I highly recommend doing those as practice. Or if you're a flashcards kind of studier, you may want to take the information on page 17 and turn those into flashcards. You'll find the answer in our learning management system called D2L.